everyone, we are here today actually finishing up notes 2-1, solve absolute value equations. So last time we got all the way through number 4 and we left number 5. So that's what we're doing today. We're finishing up number 5. So the difference today is that you'll notice I have this term outside of the absolute value bars that has a variable in it. I don't know if you noticed last time, but last time we never had a situation where we had a term outside of the absolute value bars that had a variable. So notice here we had just a constant term. Here we had a constant term, same here, and same here. So that's the difference today. And it doesn't really change too much other than the fact that it's going to take a little longer to solve. Our steps are still going to be the same. One thing I do want to talk to you about before we start actually solving this is possibilities of solutions. So first of all, I just want to point out that these graphs are not the end-all be-all. This isn't all the possibilities. But what is true is the amount of possibilities. This is kind of the end-all be-all, except for one situation that I'm not going to really get into now. Okay. The possibilities for the amount of solutions we can have when we're solving an absolute value equation, whether there is a variable term on the outside of the bars or not, is going to be we can either have 2 solutions, 1 solution, or no solutions. Now, an example of last time how that might look, because remember, last time we didn't have a term outside of the bars that had a variable. So that's why we had all these graphs last time that were just an absolute value graph with the horizontal line, because that was a constant term. Okay, so last time this is how our graphs looked. And this time, of course, with this term that has a variable, we'll be dealing with lines that have either a positive or a negative slope, not a zero slope like last time. So these are possibilities for how it might look to have 2 solutions with both types, how it might look to have 1 solution of both types of equations, how it might look to have no solutions looking at both types of absolute value equations. So let's go ahead and get into it. So first, our first step, if you look back, is isolate those absolute value bars. So we need to get rid of everything around the absolute value bars. So that 2's got to go and that negative 10's got to go. First thing I want to really be so clear on is that you're never ever allowed to distribute that 2 into the bars, okay? This is jail. You can't break in. Don't do it, okay? Just saying. All right, so how do I get rid of the 2 and how do I get rid of the negative 10? Well, you don't have to write this down, but just remember, how do you isolate this x? It's similar here, okay? So I isolate this x by adding the 5 first, then dividing by 4. We'll do similar here. So we'll add the 10 first, and y'all know I don't usually write the add 10. I'm going to circle and I'm going to move across. So I've got 2 times the absolute value of 3x plus 2 equals 8x plus 10. That negative 10 turns positive. Okay, and now I don't combine those because they're not like terms. Okay, we have a term with a variable and a term that doesn't. Okay, so a constant term, we can't combine those. So now again, I do need to get rid of this 2, and you are not ever allowed to break in and distribute that. That's not parentheses, it's absolute value. Totally different. Okay, so to get rid of the 2, the opposite, or the inverse, I should say, the inverse of times is divide. So I'll divide both of my sides of the equation by 2. Okay, so then here, of course, 2 divided by 2 simplifies to 1. And this becomes the absolute value of 3x plus 2. Notice, nothing inside the bars has changed, okay? That should remain the same throughout. Okay, so nothing has changed here. The 2 divided by 2 turned to 1. I don't need to write the 1, it's implied. Okay, here I'm going to get my red pen because remember I use this cheesy saying. I know, it's cheesy. Okay, share the love here. Divide both terms by that 2. So this will be 4x plus 5. Okay, so I have done step 1. Check. Isolate absolute value bars. Now, remove absolute value bars by setting up both equations. Let's pause for a second. Let's go back to before. Okay, how did I remove, once the absolute value bars were isolated, how did I remove the absolute value bars and split it up into 2 equations? Remember, I kept what was inside the bars the same, so the x plus 1 stayed the same in both cases, just like here, the x minus 4 stayed the same, okay? And then on the left equation, I made this a negative 1, and on the right, I made it positive. On the left, I made this a negative 3, on the right, I made it positive. Okay, and even when this was a negative in this situation, I kept this negative and I made this positive. So always what was in the bars stayed the same. On the left side, this term became negative if it wasn't already, and then positive if it wasn't already. So we're going to do a similar thing here. So again, we're breaking it up into two equations to remove the bars. The only way you're allowed to remove the bars is if you say, set it up into these two equations. So remember, what's in the bars remains unchanged. So 3x plus 2 stays the same, just like it will over here. 3x plus 2 remains the same, equals. Now on the left side, we're going to change the sign on both terms. So this will become negative 4x minus 5. Okay, both terms always, no matter what, always both terms will change signs. And then on this side, we will keep both terms the same. So no matter what signs are here, on the first one, I usually change the signs on both, and on the second one, I keep the signs the same. It doesn't matter if you do it the other way around. That's okay if you would have put the positive 4x plus 5 here and the negative 4x minus 5 over here. It doesn't matter. You're going to do it no matter what. It doesn't matter which answer goes first, really. Okay, so now remember, our next step is solve each equation. Okay, solve each equation. So therefore, you know me, whenever I solve this type of equation, I like to get my variables, my x's in this case, on the side that has the term with the highest or coefficient. So in this case, 3 is higher than negative 4. So I'm going to move variables to the left, it looks like. So therefore, constants will go on the right. Okay, so this will become 3x plus 4x equals the negative 5 drags down. That becomes a minus 2. So that's 7x equals negative 7. So divide by, oops, I almost wrote divide by x. Silly me. Divide by 7. So x equals negative 1. Right? And then on this one, since this term has the biggest coefficient when I'm comparing the two terms with variables, I'm going to go ahead and move variables to the right on this one. So then I'm going to have to move constants to the left. Alrighty, so this will look like 2 because that drags down, and this becomes minus 5 equals the 4x drags down, and that 3x becomes minus 3x. Okay, and so this is negative 3 equals x. All right, so we're done. All right, we're done solving. Now that I have solved, now I need to check for extraneous. Herein lies the fun, right? So now, of course, it's a more complicated problem. It's going to take a little bit longer. First thing I want to do is I want to write a very special note. When checking, nothing, and notice this is all caps. And you know what else I'm going to do? I'm going to underline it. When checking, nothing can move sides. I will reiterate that. I have said it. I'm saying it again. I need to I'm going to bubble this. You know what? I'm going to bubble it and I'm going to highlight it. Will that make it pop? Okay, when checking, nothing can move sides. So let's go ahead and check now. So let's make sure you can see everything. Okay, so let's check negative 1 first, alrighty? So check negative 1 first. So that means I'm plugging negative 1 into my original equation where I see x. Remember the original equation. So that negative 10 still is on the left side here. So I'm plugging into the original equation. So where I see x, I plugged in negative 1. Now let's go ahead and let's compute this. So I'm going to have to scoot up so we can see as I work. All right, so nothing can move sides. I can't add 10 to both sides. Nothing, okay, nothing. So now we're just going to work on the left first. So here, and again, hold on, let me just say, never, ever, ever, never, ever, ever, ever can I distribute in. So those absolute value bars kind of act like parentheses here, meaning we take care of what's inside here first. So 3 times negative 1 is negative 3. So we've got negative 3 plus 2 inside the bars. Okay, and that becomes, so drag down the 2, that becomes negative 1, and then minus 10 equals. All right, so now what is the absolute value of negative 1? Compute that. So the absolute value of negative 1 is positive 1. Now you can take it out of the bars. Okay, now and only now can you do that. So now we have 2 times 1 minus 10. So 2 minus 10, in other words, negative 8. So 8 times negative 1, is that negative 8? Oh, and I should have had my question mark here, shouldn't I? Bad me. Okay, yes, so we're good. So this answer is not extraneous. It's good. It's a true answer. I can go ahead and box it. All right, so I'm going to box it. So now let's check negative 3. Okay, so plug, let me show you. Plug into the original problem, 2, absolute value of 3, where I see x negative 3 plus 2 minus 10 equals 8, where I see x negative 3. So now I'm checking negative 3 for a solution. Okay, so again, nothing can switch sides and I can't distribute in. I just need to figure out what this value is in here. So negative 9 plus 2. Okay, drag down the minus 10. So negative 9 plus 2 is negative 7, right? And what's the absolute, oh, question mark. What's the absolute value of negative 7? It's positive 7. So now it can finally come out of the absolute value bars. So 2 times 7 is 14. 14 minus 10 is 4. Okay, 8 times negative 3, that's negative 24. Is this a true statement? No, it's not. That means that negative 3 is what? What's that word again? Oh yeah, extraneous. Okay, extraneous. So you would put an EXT next to that answer. All right, so we solved each equation. We checked for extraneous. We are done. So before I let you go though, so you saw how long that took compared to before. Okay, before I let you go, I just want to go over something really quick. Maybe find some room in here to write it. I'm going to write it on this so it pops. But if I were you, I would definitely write it somewhere on here wherever you have room. Okay. Here's the part I'm afraid you might get confused on. It's this part. So say for example, we had something like absolute value of, I don't know, 2x minus 5. Okay, I'm just making something up here. Equals, say this was negative 3x plus 7, who knows. Okay, so remember when I split it up, remember how that'll look. So I just want to show you how this would look when I split it up, because the absolute value bars are isolated, right? I've done all the steps to isolate my absolute value bars, and now I need to get rid of the absolute value bars. I need to split it up into 2 problems. Okay, so I need to split it up into 2 problems. How would that look? So remember, either way, the 2x minus 5 stays the same. Either way, what's in the bars stays the same. Okay, and here, on the first one, remember on the first one, I changed the signs on both. Okay, so this would become positive 3x minus 7. I changed the signs on both. On the second one, I keep the signs exactly the same. Okay, so on the first one, I changed the signs on both terms. On the second one, I kept everything the same. Now, what if you would have kept it the same on the first one and then changed the signs on both on the second one? So what? So your answers are going to be, instead of -1 first and -3 second, it would have been flip-flop. I don't care about that. Just make sure on one of them that you change the signs on both, and on the other one you keep it. Now, hold on, I'm going to give you a little nugget here, a tidbit. I'm going to check your notes, and I've just decided that if I don't see this on your notes, you don't get credit for your notes. So I want to see this. If you use a sticky like me, fine. If you put it off to the side here, fine. But I'm looking for this whenever I check your notes. So make sure you have that. We'll refer back to it. See you next time.